Hi there, Miss Barber here. I sure hope you're doing well. This lesson is titled Integration by Substitution. Many of the indefinite integral formulas are based on corresponding derivative formulas. This lesson is on a process of integration called method of substitution. This procedure is based on the chain rule for differentiation. The learning objectives for this lesson are: be able to reverse the chain rule to find indefinite integrals. Be able to evaluate integrals using substitution. And finally, be able to solve applied problems involving integration by substitution. Where is this skill used? Well, let's see. Here's an example. The marginal price for a weekly demand of X bottles of a shampoo in a drugstore is given by P prime of X equals -9,000 divided by the quantity 3x plus 50 squared. Find the price demand equation if the weekly demand is 150 when the price of the bottle of a shampoo is $4. What is the weekly demand when the price is $4.50? Notice that in this problem we're given the derivative, but we actually need the function. So we're going to have to be able to perform integration or anti-differentiation. Example, use the chain rule to find derivatives of the following functions. Part A, f of x equals the quantity 5x to the fourth plus 3 all raised to 6. We see an inside function, that's 5x to the fourth plus 3 in the parentheses. The outside function is raised to 6. So in using the chain rule, we bring the 6 down first. So let's begin. F prime of x is equal to, we bring the 6 down, and the power that was 6 lowers by 1, so it becomes 5. We have 6 times the quantity 5x to the fourth plus 3 to the power of 5. Now remember to take the derivative of the inside function, which was 5x to the fourth plus 3, and that derivative is 20 times x cubed, because that's 5 times 4, that gives you the 20. Subtract 1 from 4, that's 3. Now let's multiply common terms together. We can multiply the 6 with the 20x cubed, so that'll give us 120x cubed, and then times the quantity 5x to the fourth plus 3 raised to the power of 5. Be careful not to attempt to distribute that 120x cubed through the parentheses, because you can't. It's already raised to the power of 5. Part B, d dx of 6 times e to the power of x cubed. d dx means take the derivative of whatever's right next to me. And so when we take the derivative, using Leibniz notation, we would say dy dx equals, okay, we got a constant 6 times the function e to the x cubed. So dy dx is equal to 6. The constant comes along for the ride. The function e to the x cubed stays put. The inside function is x cubed, so when you take the derivative of it, that becomes 3x squared. Now multiply the 6 together with the 3x squared, and that product will give you 18x squared. So dy dx is equal to 18x squared times e to the power of x cubed. Part C, g of x equals 3 times the natural log of the quantity x squared plus 5x plus 8. Remember, the derivative of the natural log of x is 1 over x, but here we have a function. So when we take the derivative using the chain rule, we would get g prime of x is equal to, we've got the constant 3, that stays put, 1 over whatever is inside the parentheses for the ln, so that'll be x squared plus 5x plus 8. Remember to take the derivative of that inside function. The derivative of x squared plus 5x plus 8 is, well, the derivative of x squared is 2x, plus the derivative of 5x is 5. The derivative of 8, which is a constant, is just 0. Now let's multiply the 3 through the expression 2x plus 5. That is, we're going to distribute it. So the numerator would be 3 times 2x, which would be 6x, plus 3 times 5, which is 15. So g prime of x is equal to 6x plus 15, all divided by x squared plus 5x plus 8. And now let's go to part D. P of x equals the rational expression 3,000 divided by 3x plus 50. To avoid using the quotient rule, let's go ahead and rewrite that expression in the denominator by using a negative exponent. So you got 3,000 times the quantity 3x plus 50 raised to the power of negative 1. When we take the derivative, we're going to have P prime of x equals, the 3,000 is a constant, it comes along for the ride. Now let's take the derivative of the actual term. We bring the power of negative 1 down front. So you got negative 1 times the expression 3x plus 50, and that's raised to the power of negative 1 minus 1, which is negative 2. Don't forget to take the derivative of the inside function 3x plus 50, which would be 3. Let's multiply the constants of 3,000, negative 1, and 3 together. That would give us negative 9,000, and you still have the quantity 3x plus 50 raised to the power of negative 2. Let's rewrite this so there is no negative in the exponent. Then we'll get negative 9,000 divided by the quantity 3x plus 50 squared. Example, refer to the derivatives of the previous exercise to obtain the antiderivatives of the following functions. Part A, the integral of 120 x cubed times the quantity 5x to the fourth plus 3 all raised to the 5 dx. The question is, the derivative of what function gives me the 120x cubed times 5x to the fourth plus 3 all raised to the 5? Well, that turns out to be the function quantity 5x to the fourth plus 3 all raised to the 6 plus some constant. Let's do part B. Find the integral of 18x squared e to the power of x to the power of 3 dx. The question is, what function, when I take the derivative of it, will give me 18x squared times e to the power of x cubed? Well, we've already got that solved. That would be 6e to the x cubed plus some constant. We took the derivative of that function previously and got the 18x squared e to the x cubed. Let's go to part C. Integrate 6x plus 15 all divided by x squared plus 5x plus 8 dx. Well, the question is, what function do you take the derivative of to get that expression? It turns out that if you take the derivative of 3 times the natural log of the quantity x squared plus 5x plus 8 plus some constant, that derivative would give us the 6x plus 15 divided by the x squared plus 5x plus 8. We just did that. And finally, one more. The integral of negative 9,000 divided by the quantity 3x plus 50 squared dx. Again, what function do you need to take the derivative of to get the negative 9,000 over the quantity 3x plus 50 squared? Well, we took the derivative of 3,000 divided by 3x plus 50, and then we have to have that plus c, and got the expression negative 9,000 divided by 3x plus 50 quantity squared. But how do you do this? How do you reverse this chain rule? As a reminder, the chain rule is d dx f of g of x is equal to the derivative of the outside function f prime of g of x times the derivative of the inside function g prime of x. So the integral of f prime of g of x times g prime of x gx is equal to f of g of x plus c. Notice and pay real close attention where the integral symbol went and where the ddx notation went. Integration by substitution is a technique for undoing the chain rule. For this to work, we need to determine an outside function f prime with an inside function g that is multiplied by the derivative g prime. General indefinite integrals formulas. The integral of f of x to the n multiplied by the derivative f prime of x dx is equal to f prime of x to the power of n plus 1 divided by n plus 1 plus c, provided that n is not negative 1. The integral of e to the f of x, f prime of x dx is equal to e to the power of f of x plus c. The integral of 1 over f of x, f prime of x dx is equal to, as you would expect, the natural log of the absolute value of f of x plus c, provided that f of x and 0 are different. Next example. The marginal price for a weekly demand of X bottles of a shampoo in a drugstore is given by P prime of X equals negative 9,000 divided by the quantity 3x plus 50 squared. Find the price-demand equation if the weekly demand is 150 when the price of the bottle of shampoo is $4. What is the weekly demand when the price is $4.50? Solution. Remember, P of x is equal to the integral of P prime of x dx. We are undoing that derivative. So what we're solving for is the integral of negative 9,000 divided by the quantity 3x plus 50 squared dx, and we've actually done that already. We solved that to be 3,000 divided by 3x plus 50 plus c. So we have that P of x is equal to 3,000 divided by 3x plus 50, and then to the side of that plus c. Now we're going to use that initial condition of 4, 150. Remember, $4 for a bottle of shampoo, you get 150 sold. And so we're going to use that to solve for that constant c. So you get 150 is equal to 3,000 divided by, and where the x was, put in 4. So you got 3 times x plus 50 plus c. And that's going to be equal to, let's do some of the arithmetic, 150 is equal to 3,000 divided by 3 times 4 is 12, 12 plus 50 is 62, and we still have plus c. So now algebraically solve for c, that is, you can do 150 minus 3,000 over 62, and you get that c is approximately 101.6129032. The price-demand equation is P of x equals 3,000 divided by 3x plus 50, and then plus 101.6. Now we want it for $4.5. So we're going to put in 4.5 every place there's an x. You got 3,000 divided by 3 times 4.5 plus 50, and all of that plus 101.6. Use your calculator here. And it comes out to 148.8440945. The weekly demand when you are charging $4.50 per bottle of shampoo is approximately $149. So what did you notice here? At $4, the demand was $150. You raise the price by 50 cents. The demand goes by 1. That's your job to decide which is a better economic output for the company. Steps for integration by substitution. What we're looking for is if you have the integral of f prime of the inside function g of x times the derivative of the inside function g prime of x dx, and that's equal to f of g of x plus c. How do we get there? Well, step one, identify a u in terms of x. We'll do plenty of examples. Let me just get through the steps right quick. U is the g of x in the above integral. We're going to compute du and express the integrand entirely in terms of u. You should have no x's left, and the entire integrand should be multiplied by du. Find the antiderivative in terms of u. We're going to integrate in terms of u, that's what that means. And finally, remember to substitute back the terms of x. That is, if you're asked to find an integral in terms of x, even if you solve it substituting with u, you still have to make sure that your final answer is expressed in terms of x. So let's try an example. Find the indefinite integral, that's find the antiderivative of, let's see, 3x squared plus 7x minus 2 raised to the 11th times 6x plus 7 dx. We've got to figure out what's the outside function, what's the inside function, and a clue to look for is if I take the derivative of 6x plus 7, or if I take the derivative of 3x squared plus 7x minus 2, do I get one of the other functions? Let me show you what I mean. So I'm going to let u equal 3x squared plus 7x minus 2. Look what happens when I take the derivative. U becomes du, and the derivative of 3x squared is 6x, the derivative of 7x is 7, the derivative of 2 is 0, and it's in terms of x, so we've got dx. Now you see a substitution. Let's do that. We'll take that original integral, that's 3x squared plus 7x minus 2 to the 11th times 6x plus 7 dx, and express everything there in terms of u. What does that look like? It's going to look like much simpler, right? Because where the 3x squared plus 7x minus 2 was, we put in u. And where the 6x plus 7 dx was, we replaced that with du. Now that's just a matter of using the power rule for integration to find the antiderivative. Let's do that. The integral of u to the 11 du is, remember, you just add 1. So you're going to have 1 divided by 11 plus 1, which is 12, u to the power of 12 plus c. Don't forget, though, your answer has to be in terms of x. So where u was, let's put back the x term, and we'll get 1 over 12, that's there. Where u was, we replace it with 3x squared plus 7x minus 2 to the power of 12 plus c. Example, find the indefinite integral e to the x divided by the quantity 7 plus e to the x dx. To do this, we're going to have to be able to find the u and du. I'm going to start with let u equal what's in the denominator. That's 7 plus e to the x. And that's because when we take the derivative, u becomes du. The derivative of 7 is 0, so all we have left is e to the x dx. What does that substitution look like? Well, we got the integral e to the x divided by 7 plus e to the x dx. And while it's not necessary, I'm going to separate the terms just so that we can see the substitution better. I'll express it as 1 over 7 plus e to the x times e to the x dx is exactly the same indefinite integral we started with. Now we can actually make the substitution, and we've got 1 over where the 7 plus e to the x was, we put in u, and where we had e to the x dx, all of that entire expression is replaced with du. We know how to integrate 1 over u du, that's a ln, so we'll get ln of u plus c. Now remember, your final answer has to be in the same variable that the original problem was in. So where u was, replace it with what we started out with, which was 7 plus e to the x. And you get ln of the quantity 7 plus e to the x. And don't ever forget the plus c when we're working with indefinite integrals. Example, find the indefinite integral of x squared e to the 4x cubed dx. Well, let's begin. We need to let u equal, and as a general rule, look for the expression that has the higher degree, especially if it's greater by just 1. For example, if I use 4x cubed, not e to the 4x cubed, but just the power 4x cubed, when I take that derivative, I'll get du equals 12 times x squared dx. Now, that doesn't quite look like the integral we're asked to solve, but guess what? How about if I divide by 12 on both sides? Then 1/12 du is equal to what's in the original integral, x squared dx. The integral of x squared times e to the power of 4x cubed dx is equal to, and I'm just rewriting the order a little bit, okay? So I'm going to switch and have e to the 4x cubed first, and then I'm going to put x squared dx next to each other because that makes the substitution a little bit more optically pleasing. What do I mean by that? Well, where I had e to the power of 4x cubed, I'll replace the 4x cubed with u. And where we had x squared dx, I'll replace that with 1/12 du. So now everything is in terms of u. I'll go ahead and rewrite that by putting the 1/12 on the outside of the integral sign. It's a constant. It just comes along for the ride. And let's integrate. We get 1/12, and the integral of e to the u is e to the u plus c. We have to remember to substitute back in terms of x. And so where u was, we're going to put in 4x cubed. So the indefinite integral of x squared e to the 4x cubed dx is 1/12 times e to the power of 4x cubed plus c. Another example, find the indefinite integral dx over 3x plus 5. Let's begin. We need to be able to find an inside and an outside function. I'm going to say let u equal the denominator term, which would be 3x plus 5. Then when we take the derivative, we'll get du on the left-hand side and 3 dx on the right-hand side. Not quite what's in the original indefinite integral, but let's go ahead and divide by 3 so I get 1/3 du equals dx. We'll take that original indefinite integral dx divided by 3x plus 5. And I'm going to separate the terms, okay? So instead of having dx in the numerator, I'm just going to make it a factor. It's the same thing. So now I've got the integral of 1/3x plus 5 dx. Because this will give me 1/, and where 3x plus 5 was, I put in u. And where dx was, I put in 1/3 du. Let's rewrite that. I'll put the 1/3 on the outside of the integration symbol because it's just coming along for the ride. So you got 1/3 the integral of 1/u du. We know how to integrate 1/u. That gives us ln of u. So we have 1/3 ln of u. Don't forget the plus c. And also remember to substitute back in terms of x. So where u was, we'll replace that with 3x plus 5. And we get 1/3 times the ln of 3x plus 5 plus c.